Hello, everyone. Firstly, I'm going to introduce myself. My name is Dharmen Tiwari. I have done BTech, MTech from Jamia Millia Islamia University, New Delhi. And I have 6 years of teaching experience in various coaching institutes. I am 3 times GATE qualified. I also secured All India third rank in Jamia entrance examinations. So today I'm going to start the application of integration, where we use the integration. Basically, in this lecture, I'm basically start the application of integration, where we use the integration to find out something. Okay, so basically, we use the integration to find out energy stored in the capacitor, energy stored in the inductor, and also we are using integration to find out the area of any solid. Either it will be 3D figure or it will be 2D figure. Okay, so in this lecture, we basically discuss to find out the area of only 2D figures. Basically, we discuss some basic concepts over here. And then after that completion of basic concept, we practice some questions on the basics, on the basis of the basic concepts. Okay. This is my introduction. So let's start with the first concept. Just wait. Okay. Yes. So let me introduce firstly how we find the area of any curve. Like in case of rectangle or triangle, suppose a rectangle like this, you have length, you have breadth. So you easily find out the area. Area is what? Length into breadth. But in the case when there is a non-linear functions, when there is non-linear function, then how we find those area enclosed by the non-linear functions? For example, if the curve like this, suppose say x equal to a to x equal to b. This is not a linear function. It may be either quadratic or maybe cubic, depending on the graph. So how we can find this area in between from x equal to a to x equal to b? How we find? We can easily find out with the help of integration. Integration has a very important aspect to find out the area of any 2D figures, also 3D figures. But in case of the JEE syllabus, we will only consider the 2D figures. Okay. So let's see. In the first case, let's see, we make a very small strip, and the width of this strip is very much thin and called dx. Okay. And say this function is fx, y equals to fx. So what is the length of this function? Is nothing but fx. So this strip seems to be very similar to a rectangle. Very similar to a rectangle. So what is the area of rectangle? Now area of rectangle is what? The length. Suppose the length is a function value, so fx. And what is the breadth? Breadth is nothing but dx. This is the area of only this strip. Now we move this strip from x equal to a to x equal to b in order to find out the complete area. In order to find the complete area. So this can be done with the help of integration. This can be done with the help of integration. So from x equal to a and x equal to b, if we integrate this one, we get the complete area in between x equal to a to x equal to b. Right? So this is the basic concepts. Later on later on this lecture, I will discuss some basic problem on this concept. Okay. So this is the first case when the complete graph is above the x-axis. Okay. And we also know that one very important concept, that is area never be a negative. Area never be a negative value. So whenever there is a calculation comes out to be negative value of area. So what is the meaning? We take mod of this value, right? Suppose this value is mod. Suppose you get -3 value. That means the area is 3 units. Okay. So let's discuss the next concept. The next concept. When there is involvement of two graphs. Okay. Suppose say this is graph f of x. Okay. And this graph is called say g of x. And we are going to find on these two graph is non-intersecting. Okay. So in order to find the area in between x equal to say x equal to a to x equal to b. X equal to b. So how we find out this area? Okay. We again make the same concept, use the same concept to find out the area. Make a strip that is very much thin and say this is dx. So now what is the function value? What is the length of this part? It is nothing but fx minus gx. Okay. It is the difference between the upper portion of the function, upper portion minus the lower portion. So now the area will be fx minus gx. This is the supposed length. And what is the breadth? It is dx. And now integrate from x equal to a to x equal to b in order to find the complete area from x equal to a to x equal to b. Again, if this area comes out to be negative, take mod value because area cannot be a negative value. Okay. So this is the approach when there is two function is involved. Suppose say, for example, if we take y is equal to x square and x equal to y square. So how the graph is y equal to x square. Y equal to x square seems to be like this. And x equal to y square. So how you find this area? This can be done. This function minus this function, integration dx. This point, say 1, 1. If we solve this 1, 1, and then integrate from 0 to 1, f of x minus g of x dx. This is the best approach to solve any question based on the application related to integration. That is the application of integration to find out the area of any curve. This is the best concept. Okay. Okay. Now the third case. Third case is what? Yes. If the graph two function is given and those two function are intersecting function, and we are going to find out the area in between the intersection part. So say this point x equal to a and this point x equal to b. Sometimes these points are not given. Sometimes these points are not given. So how you find this point? At this point, and at this point, fx and gx are equal. When you equate fx equal to gx, you get the value of x and y very easily, and then put the limit of x because our strip varies according to the x-axis. We take another case where the strip varies according to the y direction in the later on classes. Okay. Firstly, we'll discuss only the question based on the strip varies on the x-axis. Okay. So in this case, again the same concept I'm going to use. Take very small width strip, say called dx. Okay. Now, what is this value? Say this function is fx and this function is gx. Okay. So again, fx minus gx is your length and then dx in order to find out the complete area. Okay. So this is the approach from x equal to A to x equal to B. Okay. In order to find the complete area in between the intersection part, we just integrate from x equal to A to x equal to B to get the complete area in between the intersection point. Okay. Now the fourth case. The fourth case is one of the important one. When the sum part of the graph lies below the x-axis. Lies below the x-axis, that means there is some negative area. So how we deal with this one? So let's see. Suppose we have a graph like this. And I'm going to find out the area from x equal to A, x equal to B. Okay. Now make the strip over here. And also make the strip over here. Okay. So how we can do this? And say, if we know this point, say x equal to C. So that means we can say A is less than C is less than B. That means C is in between A and B, right? C is in between A and B. So how we can calculate this area? We can easily calculate. We know the property of integration. We can break down the limits on its interval. So we break the limit from x equal to A to C. Firstly, we calculate area from x equal to A to x equal to C. And we use function fx dx. And take mod of this value. Plus, now this area, again, from x equal to C to x equal to A, I'm going to find out. So from x equal to C to x equal to A. Again, the same function fx dx. This again mod value because this area is negative. So to make it positive, take the mod value. This is the complete area. So how we can find out? We just take mod value, that portion which is below the x-axis, in order to find the complete area. Okay. Is this clear? So this is the fourth concept. Now the last concept, which I'm going to discuss over here. Is there any problem in this concept? I guess no problem. You just firstly integrate from x equal to A to x equal to C to get the upper portion of this area. And from x equal to C to x equal to B, sorry, this is B, not the C, this is B. From x equal to C to x equal to B, right? From x equal to C to x equal to B to get this area. So from x equal to C to x equal to B, we just integrate to get the lower portion of this area, and then take the mod value and add these two areas to get the complete area. Okay. Okay. So let's start the fifth concept. Yes. The fifth concept is very much the previous one. If you look at very carefully, it's just the previous case, the either maybe third one or maybe second one. You can easily solve this question. Suppose there is one graph like this and one graph like this. And I'm going to find out the area. Say this point is x equal to C. And this point x equal to A, this point x equal to B. This function is fx, say, and this function is gx. Okay. Now, we have two approaches to solve this question. First approach, calculate this area. Calculate this area. Let's see how. So from x equal to A, so from x equal to A to x equal to C, this graph is fx minus, because fx is at higher values and gx is at lower value, fx minus gx dx, plus, without taking the mod value, but taking the function value. Take care of the function value. You cannot use the mod value. So how? It is gx, because gx now is at higher values of function, minus fx dx. And then from x equal to c to x equal to, this function is, this integration will be positive, and this also positive. There is another approach. How we can do that? We can easily calculate this area from x equal to a to x equal to b. Only fx minus gx. Take the mod. You can also calculate with this help. You get the same value from these, about these two results. Okay. Is there any problem? This is the I think best way, because this concept is used in most of the cases. So my preference, you have to use this method so that you get more clarity on this concept and use to solve more question on this based on this concept. Okay. Now let's start some example based on these basic concepts. Before I'm going to start some example, let's take one example when the strip varies on the y-axis. Okay, so let's look at. Suppose our function like this. Okay, in this case, either have to take a strip. We have to take a strip like this. You can also take the strip on the x-axis, but in this case, it is suitable to make strip on the y-axis. This width is now dy, and y suppose say varies from 0, a to 0, b. Now I'm going to find out the complete area. Integrate from y is equal to a to y equals to b. Now it is f of y dy. So this function is called f of y. Okay, because now it is the function of y, because the strip varies on y-axis. So with this concept, we can easily calculate area. So either you have to take strip on the x-axis or you have to take strip on the y-axis. It basically depends on the questions, or it may also depend sometime on your choice. But most of the cases, most of the time, you just make strip parallel to it make the strip on the x-axis only. That means parallel to the y-axis. Okay. So let's start one or two numerical problems based on this concept. And after that, we'll wrap up this concept. Okay. Yeah. So find the area enclosed by the circle x square plus y square is equal to a square, where a is the radius of the circle. And we know that if a is the radius of the circle, then area of the circle is nothing but pi a square. Now let's calculate with the help of integration. This area I'm going to calculate with the help of integration. Okay. So first start. This is circle having center at origin. Okay. So this is y-axis and this will be x-axis. So how we can calculate this area? If we look this one, it is very clear that this circle is divided in 4 equal parts, because this is a circle centered at origin. So in order to find out the complete area, we just find the area of only single part and then multiply with the help with 4 to get the complete area. Okay, we're just going to find out the area of only single part, that is first quadrant. So make the strip over here. This is function fx, and that is y x square plus y square is equal to a square. Find out the value of y. Y is equals to under root plus minus a square minus x square. But in the first quadrant, we just take plus value. So it will be y equal to plus under root a square minus x square. This is the function value. Now, what is this point? This is nothing but it is the radius of the circle. So coordinate of this point is a comma 0. And this will be 0 comma a. So our strip is moving from x equal to a to x equal to 0 to x equal to a. We move our strip from x equal to 0 to x equal to a to get the complete one portion of this area. Okay. In order to find one portion complete area, we just move the strip from x equal to 0 to x equal to a. So let's see. So integration from x equal to 0 to x equal to fx dx. Now from 0 to a, what is fx? fx is nothing but root a square minus x square. So root a square minus x square dx. Now we very well know this integration. This is the standard integration. We know the formula of this standard integration. So what is the integration of this one? It is nothing but x by 2 root a square minus x square plus a square by 2 sine inverse x upon a, and put the limit over here from 0 to a, because this is the standard formula. Now we just put the limits. When we put the upper limit a by 2, when we put x equal to a, so a by 2 under root a square minus a square. So a square minus a square plus a square by 2 sine inverse a upon a. This is the upper limit minus the lower limit. When we put lower limit 0 into something, when we put x equal to 0, so 0 into something will be 0, and sine 0 upon a, sine inverse 0, that is nothing but 0. So this complete portion will become now 0 when we put the lower limit x equal to 0. So it will be 0. Okay. So this portion also 0, because a square minus a square, 0 into something is 0. So the answer will be a square by 2 and sine inverse 1 by 1. Sine inverse a by a cancel out. So it will be sine inverse 1. And we very well know sine inverse 1 is nothing but pi by how much? 2. So it will be a square by 2 into pi by. This is the area of one portion. This is the area of one portion. In order to find out the complete area, we just multiply with 4. So this 4 will cancel out with this 4. So answer will be pi a square. That is nothing but this. Okay. Got it? Now let's try one more question, one more simple example. Okay. So suppose y is equal to x square, comma, x is equal to y square. So how we find this area? How we find this area? Let's see. Okay. So y equals to x square. Y equals to x square. The graph is, this is y axis. This will be the x axis. And x equal to y square. This is y equal to x square. So in order to find this area, firstly, I'm going to find out this point. And how we can find this point? We can easily equate this equation. Put the value of y in this equation. So x equals to x square. Okay, value of y is x square. So x square. So x to the power 4 minus x is equal to 0. So x, take the common x cube minus 1 is equal to 0. So x equal to 0 and x equal to 1. When we put x equal to 1 over here, we get y1. So this point is 1, 1. Okay. In order to find the area, we just make the strip. And this is fx. And fx is what? Y equals to x square. And this is, say this is fx. And say this is gx. Right? So fx is which one? This one is fx. And what is this? This is x equal to y square. So what is the value of y? Y equal to root x. Okay. So what is the area now? Area is now this fx minus gx, fx minus gx dx, and x varies from x equal to 0 to x equal to a. This strip varies from x equal to 0 to x equal to a. So it will be from x equal to 0 to x equal to a. A means that is x equal to 1 in this case. So now fx is what? Fx is nothing but x equal to y square. So what is the value of y? Y is root x. So it will be root x minus. What is the gx? Gx is nothing but y equal to x square. So what is the value of y? Y is x square. So x minus x square integration dx from 0 to 1. Now what is the integration of root x? Root x integration x raised to 1 by 2 plus 1 divided by 1 by 2 plus 1 minus x cube by 3. Now put the limit. When we put the lower limit, it will automatically be, will become 0, and this will be x 3 by 2, 2 by 3 minus x cube by 3. Limit from 0 to 1. So it will be 2 by 3 minus 1 by 3. And we put the limit, when we put the lower limit, it will become 0. So 2 by 3 minus 1 by 3. When we put x equal to 1, no effect because x has a 1 value. So it will be 1 by 3. So area in between this curve is 1 by 3. Okay. Okay. That's it for this class. Thank you guys.